So in this video, we're going to take a look at the Forth programming language. This is an interesting language. It's a stack-based language. It was created around 1970, and it seems to have, at the time, been designed to run on really small machines. And I was thinking in the 8-bit era, what's the smallest computer I could think of in terms of memory and storage? And it was the VIC-20. And the VIC-20 has just 5K of RAM, and this emulated VIC-20 has just a tape cassette. So we're going to play around with a cartridge called VIC-forth, written by Tom Zimmer, all the way back in 1982. The cartridge itself is an 8K ROM. It includes the editor, an interactive development environment, and a pretty good API for some graphics and sound on a VIC-20. So let's get right to it. Let's check this out. Forth is a language that's all about words. Everything is a word in a language. And in the interactive editor that we're in now, we can just type in words and press enter, and it will do things very similar to like a basic environment or the console part of a web browser for JavaScript programmers. So just by pressing enter, we've entered no command, and we get the word OK. This means that the command executed with no errors. Well, that's not a very exciting command to execute. Just pressing enter doesn't do anything. So the first word we're going to learn together is CR, which stands for Carriage Return. So by typing CR as a word and pressing enter, it does a carriage return. Nothing terribly exciting here. We can put multiple words on one line together, and we do that by separating them with spaces. So we can do CR. We get 2 carriage returns. We can do 3, and we get 3 carriage returns. Very straightforward so far. Another word we can use is called .quote. Yep, that's the actual name of the word. And this is kind of like print or console.log for you JavaScript programmers. If we press a space, because every word has to be separate of the space, and this particular word takes a text parameter. And we can type anything we want, and we can end it with a quote. So we're going to type in hello world. Now you have to have a space after the .quote and before the parameter. So we press enter, and we get hello world. In this version of Forth, as you could tell, it immediately executes the code right where we pressed enter, and when it ends, we get OK. So we can mix this idea with our CR word, CR. We can do .quote. We can do hello world, quote, space, and CR, and now we'll get a carriage return, hello world, and OK. And just to kind of reiterate how this space works here, because it's kind of important, if I wanted to actually have a space before the hello world, you can do that by just putting a space there. So you have to have a space between .quote and the text we're going to print, but it's not collapsing the white space or anything like that. And here we go, hello world. So what happens if you typed in a word that the environment doesn't recognize, like foozle? Well, you get what looks like a cryptic error message. What the interpreter is telling us is, hey, foozle, that word you put in, and that's an arrow pointing at it, has a question mark, which means it's an error, and you get a number. Well, the VIC-20 version of Forth is so small, there's not even enough room for the error messages. Well, there kind of is, but they took the error messages out to save more space. And here's the table of the error messages. And a 0 means VIC-forth does not know this word. So cool. If you actually wanted the error messages back later in a manual, they give you some code where you can reinstall the error messages. But there's only a handful, and we don't really need them for what we're doing. So we've used 2 of the built-in words in Forth, CR and .quote. Well, we can define our own words, and it's super, super easy. And we do that with the defined word. And the defined word is actually just a colon. And like all words, we got to put a space before we put in the rest of it. So the way define works is you do a colon space, and we'll just call that define. We're going to create a word called HW, so it's really quick to type. You type a space, and then you type in the command that you want it to be. And we'll just use what we have above. A carriage return, a .quote, a hello world, a carriage return, and then you end it with a space and a semicolon. So everything between the HW and the semicolon is the definition of our new word. So you could read this as define HW as cr.quote hello world, cr semicolon. So we press enter, and we get a very simple OK. Now that that word is in our dictionary, we can just type in HW, And the output is the definition that we just created. We can also define words that build upon words that we've just defined. And we can call this to-HW, and it can just simply call HW twice. So to-HW, we'll call hello world twice. So applications are built by defining words that are built from other words. So let's talk about the dictionary for a second. Forth comes with a dictionary of words. Clearly, we just used a couple that were built in, and it comes with over 250 words. We can see the dictionary by typing v-list. And I'm going to run this for a little bit and press run stop here so we can stop the list. So at the very top, we see the two words that we created, to-HW and HW. These words are the user dictionary, words that we defined. The next two words are editor and forth. Those two words, when you turn on the VIC-20, are copied from the ROM into RAM. And one is for the editor, which we haven't seen yet, and the other is the interactive development environment, which is what we're using now. All the other words that you see listed there, they store an address of BF. Those are in the ROM of the cartridge. The cartridge is an 8K cartridge that sits from A000 to BFFF. But more importantly, it's the words that matter. And you can already see some interesting words like B-ground and border and noise and soprano and tenor. So we see some graphics, we see some sound calls. This language does come with a lot of functionality out of the box. So let's say we wanted to erase our words. We just want to start over. You know, we've created to-HW and HW. I just want to start over. We could type in the word empty, and that is going to delete all of the user-defined words that we typed. And if we type v-list now, you'll see that we're right back to where we started when we turned the machine on, and those two definitions are gone. Well, what about words that need values passed to it? So one particular one is border. So border sets the color of the border in our screen. Right now it's a kind of a green. Well, values are passed before the word. In most languages that I've worked with, the parameters come afterwards. Well, in Forth, they come before that. There's a few exceptions to that, clearly. As we just saw with .quote, the text parameter comes after it. But for any numeric parameters, they come before the word. And the reason why that is parameters are passed on what is called the stack. So if I press enter here, we'll see that the border turns to blue. But what's actually happening? Well, there is a stack, and by putting a number by itself, like 6, it puts it onto the stack. And then when we call the word border, border pops the value off the stack and uses that to set the border. Now, if I did a 6 by itself and just press enter, it says OK. That's great. I can type in 7, press enter, OK. And if I type in border, it's going to pop the 7 off the stack because a stack is in a last in, first out structure, and it will turn yellow. Well, that 6 is still on the stack. If I type in border again, it'll set it to blue. Now, we know the stack is empty. What happens if I run it again? Well, I get an error 1. And if we look at our error table that we talked about earlier, it says the data stack is already empty. And that is how we pass values to words. Now, there's another simple word we can use to see the stack in action. So if we pass in numbers like this, 5 different numbers, remember, every word is separated by a space. Because they are numbers, it's going to put onto the stack 1, 2, 3, 4, and 5. We can use the dot word, and what dot does is it pulls the number off the stack and prints it to the screen. So here we're going to get a 5. If I pull the next 4, you can clearly see 4, 3, 2, and 1. And of course, if I try to do it again while the stack's empty, we get that error 1. So what other interesting words can take a value from the stack? Emit is an interesting word. Emit will take a value from the stack, like 65, for example, and it'll print it to the screen. The value that it's looking for is an ASCII character value. So if we go to our VIC-20 programmer's reference and go to the section where it lists all the ASCII values, you can see that 65 is the letter A. So if I press enter here, we'll get an A. That doesn't seem terribly exciting on its own. Not too often we want to print out characters by number, but the VIC-20 has another interesting feature of its ASCII characters. They don't just print letters. They can change the color of the cursor, and they can clear the screen. They can do other things that are clearly very useful. For example, 147, as you can see, is the equivalent of pressing Shift Clear. So if I emit that, my screen clears. 5 is the equivalent of pressing Control 2 to make the color white. There it goes. Okay, let's press run, stop, restore. So we used ASCII characters 5 and 147 to turn our cursor to white and to clear the screen. Wouldn't it be easier though if we assigned words to those values so our code's easier to read? Well, we can do that by defining a word. We can call this key clear as 147. And that, of course, will put 147 in a stack, and then we can call emit after that to clear the screen, like so. But there's another way to do that. While we can define a word to do that, we can also define a constant. So let's empty out our dictionary, and instead what we're going to type is 147 to put the clear screen ASCII character onto the stack. The word constant, this is a built-in word into the fourth language that will define a constant out of the number that's on a stack, and we're going to call it key clear. And then we can do the exact same thing we did just a moment ago by typing key clear, using it as a word, but what it's going to do is put the constant 147 on a stack and emit. So what's the difference? Constants take less memory and execute quicker than defining a word to do that. And they make code more readable. So now we have just enough knowledge to create a working program, a program that will clear the screen, set the border and background colors, and write hello world. So let's adventure into the editor. So to do that, let's start by pressing run, stop, restore. So before we jump into the editor, just a quick word about memory. So the VIC-20 has 5K of RAM. And the way VIC-forth slices and dices it up is the 2K is for, 0 page, the CPU, the memory of the screen, some kernel routines, and some logic. That leaves us 3K of memory. Well, 1K of those is dedicated towards the user dictionary. And we saw a glimpse of that earlier. The other 2K are for source code. So the way the editor works is interesting. We get 2 pages of code because each page is 1K. And source code is divvied up like this. Each page is 16 lines at 64 bytes each. And while we're here, we can learn a new word, asterisk. Asterisk, kind of like plus, minus, and divide, will take 2 values off the stack, multiply them, and put the value back on the stack. And if I press dot, which if you remember, pops the value off the stack and shows it to us, is 1024. So in any case, with 5K of RAM, the unexpanded VIC, we have 2 pages of source code. Now, if you were to add in an 8K or a 16K or an 8 and a 16 for 24K, Forth will automatically recognize it and give you more pages of memory for source code. I think that it goes up to 10. And if you wanted more to 10, there's a couple things you can do to kind of shift memory between the dictionary, which is where our compiled code is, and the editor. But let's get to the editor. So how do we get into the editor? So to edit a page, we put the page number on the stack. So we want to edit page 1, and we type in the word edit. And this will bring us to the editor. So what are we looking at? A screen full of garbage and some blank lines at the bottom. So the cartridge does not initialize the 2 pages of memory for text. It's just there. And you can kind of see up here there's a cursor, and I'm using the cursor keys to move it around. And the very far right number there is the column that we're looking at. And this goes all the way over to 64. And that first number, that 1 there, is the page ROM. And at bottom here is the interpreter. This is where we type in commands for the text editor. But we can also use it interactively and do things like hello world. Interesting. In order to clear the editor for new text, we use the word wipe. And now this page of source code is cleared and ready to go. We can type to edit to go to the second page, and we can wipe that out as well. We can press B to go back a page, and N to go forward a page. And that's how we get to our 2 different pages of source code. So I'm going to show you just enough commands in the editor to be useful. There are a ton of cool commands to play with, but I'm going to put you to sleep if I went through each and every one of them. So as you can see, our cursor is at 0, 0. It's at the very top part of the screen. If we want to add text to the screen, we use the P command to put text at where the cursor is. So we're going to do P space, and it's a word, so you got to have a space. And we're going to do a comment. And the way a comment works, it's a open parentheses, which is a word also. I'm going to put a space. And we're just going to type in hello world, and then you put a close parenthesis. Doesn't have to have a space here, but we could to make it look decent. And now we've put text into the top part of the editor. Now let's say we wanted to add some text to the end of this line. We're going to move the cursor to the end of the line. We can press the insert key, and that puts us in insert mode. And now whatever we type appears up here. We're going to type in the word empty at the end of the first line here. And then we're going to press not enter, but F5 to go to the next line. Pressing enter pulls us out of insert mode, and now we're back here in this kind of command mode. So we put empty at the end of our first line. What is that going to do? When we do run our program, it's going to empty out the dictionary, so any words that we define here in our source code will be defined with fresh new entries. So let's start by putting in our constants. So we're going to put in, by using a P, a 147 constant for clear screen. Okay, and you'll see that it put a line of text in. Now, if I want to put a line of text in under the line I'm on, I can use the U command. So we'll do a U, 5, constant white, and it'll put a line underneath it. And we'll use the full screen editor here just to try it out again. We're going to press insert. So now we're typing up here, and we're going to do 0 space B ground. That's going to set our background to black. And then we're going to do 0 space border to set the border to black. Now I hit enter because you're going to do that a lot in this editor by accident, and I'm kind of over here. Down at the bottom, you can put a line number, and it starts with 0. So I can type in 4 space, and you do a T, that moves the cursor to the beginning of the fourth line. Now let's put the clear screen command in. So we can do a P space, clear screen emit space, white emit. So that's going to clear our screen and change our cursor color to white. Okay, now we'll use U to put the next line of text underneath it. And we're going to do dot quote, hello world, CR. And then for the last line of code, we're going to use a semicolon S. A semicolon S tells the interpreter to stop interpreting and to stop looking for more code after it hits this line. There seems to be an issue once we save this tape and load it back in, that if this semicolon S isn't there, the program crashes when you start it. But it only seems to happen after you load it back in from tape. So as a good habit, we're just going to put in semicolon S at the bottom. Cool, now that we're done keying in our program, we're going to press run, stop, restore to get back to the command interpreter. So to make sure that our program is in memory, we can use the list word. So we'll put the page number, which is 1, and we do list, and it's going to list all 16 lines of code that's on page 1. So how do we run it? So we use the load command. So we're going to tell the interpreter, page 1, load this into the interpreter. And what it's going to do is it's going to key all those commands in as if we're typing it from the keyboard, effectively running our program. And there we go. We got a blank screen with hello world. Fantastic. So before we dive into some more complex interactions, let's save our work to tape. So using our virtual tape drive here, we're going to rewind our tape. And to write the source code to tape, we choose the screen number, which is 1, and we use the word write. And say press record and play on tape. So using our little virtual tape drive, we're going to press record, and it's going to record our source code to tape. So it takes a few moments to save a file to tape. I believe that counter goes to 12. So we'll just give that a few moments to save. This is a tape cassette. It is most definitely not the fastest storage medium in the planet. All right, we're almost there. We're at 8. Cool, we've saved it. So what you want to do in the real world is you'd hit stop, and then you'd rewind the tape so we're ready to load it in our next section. So now let's try loading it in. So how do we do that? Well, we're going to restart our computer. In the emulator, it's just Alt F12 in Windows. And now we're back in VIC-forth, but this time, because we restarted the computer, we have the garbage in screen 1, and we want to load it from tape. So how do we load it from tape? We can type in 1 space and read, and what that's going to do is go to the tape and read it into the editor, or we can use loads with an S. So this does two things. It's going to load the code into the editor. We're going to press play since this does take a minute. This is going to go to tape, and it's going to load the code into memory. But then it's also going to just run what's on page 1. So it kind of does it in 1 command instead of 2. So it found our program, and now it's reading in the source code. And of course, our program runs. Well, now that we have our program loaded, let's get a little bit more fancy with Hello World. And what we want to do is we want to animate it by adding some colors and have it cycle through the words hello and world. So when creating animations, we know we're going to need a routine that's going to pause just for a moment so we can control how fast things happen. And the way that we're going to write that is by using a loop that just iterates a number of times and doesn't do anything. So how does one write a loop in Forth? You can't run loops interactively, so we'll have to make a word. So we're going to define a word called D, which is short for delay, and you kind of put it in backwards, and I'll explain to you why in a moment. So we want to loop 20,000 times. 20, 1, 2, 3, 0. So what's happening here is we're putting 20,000 onto the stack, then we're going to put 0 onto the stack, and then we're going to call a word called do. What do does is it reads in from 0 by pulling the 0 off the stack through 20,000 and pulls that off the stack. Now we're not going to do anything, so we're just going to use the word loop, put a space and a semicolon, and press enter. So now we've defined our loop. Normally you would insert words between do and loop to do the thing that you want to do, but we're just burning time, so we don't really care. So let's run our word by typing D and pressing enter. Excellent, and as you can see, it paused for, I don't know, 2 seconds or so. Perfect. Let's add this to our program. Let's go into the editor. That's a problem. Our color is white and the editor is white. So we're gonna press run, stop, restore. 1 space edit to get back into the editor. I'm gonna put the cursor this line here, and we're gonna use a new command, S. If I press S and enter, it just kind of moves things down a line. So now we're gonna do an insert. We're gonna define a word. This time we're gonna call it delay. And I only want it to be 75 cycles instead of 20,000. We just want it to pause for just a tiny moment. All right, so there's our delay loop. All right, so let's bounce out of here for a moment. Run, stop, restore. Now we need a number generator of sorts. We're going to get a little low level here now, and this is kind of the fun part of Forth, is we're going to interact with the VIC-20 and the Jiffy clock. The Jiffy clock in the VIC-20 is 3 bytes of memory, and it just keeps ticking up in values 60 times a second. And we only care about one of those addresses, and that address is 162, because that number ticks up, and when it reaches 255, it goes back to 0. So how do we read from memory in Forth? Of course it uses the stack, right? Why wouldn't it? So what we want to do is we want to read the value in memory address 162. Now we know if we put a dot here, it's going to put 162 on a stack, and dot is going to pull that value off the stack. What we need is a word that takes the 162 and pulls the byte of memory out of that address. And that word is cat. Okay, and we pressed it, and we pressed enter. It went to that memory address, grabbed that byte, put it into memory, put it onto the stack, and if we press dot, and we can see that the value is 236. So cat stands for character fetch. So let's break down what's happening again. 162 goes onto the stack. cat looks at that as a memory address, reads the value, and fetches it 1 byte. The C for character means 1 byte. And then it puts that value that's in that memory just on a stack. And of course, dot, which we're going to add to this line, is going to pull that number out and put it on the screen. And every time we run it, we're going to get a different number. So this will bring us back a number between 0 and 255. Well, the problem is we need a value between 0 and 7 because there's only 8 colors available to the VIC-20. And if we use any number above 7, it will cause some problems. So what we really want to do now is take that number and apply binary mask so we only keep bits 0 through 3. So let's say, for example, that we ran that command and we had a 255, which in binary would look like this. Okay. What we want to do is do a logical AND for these 3 bits on the end here. Okay. So we only end up with those 3 bits. All right? That gives us a value between 0 and 7. So for example, if this was the binary value that we retrieved from Jiffy clock, by applying our mask with an AND, we'd end up with just the 101, just those 3 bits. Great. So now I pressed enter, and of course it thought I was typing stuff in, so we got all this stuff on the screen. So we're going to clear the screen here with run stop restore. And now we're going to create a function that does exactly this. So here's how it goes. We're going to define a word called random color. We're going to look at memory just 162. We're going to use C at character fetch to go grab us the value at that memory location, and it puts that value onto the stack. Now we're going to put in that mask that we saw, which was 40111, which is 7 in decimal. And you can see from our handy dandy calculator here that is a 7. We're going to do an AND. And what the AND word does is a new word, is it takes the 2 values off the stack, our 7, and whatever value this returns to memory address, and it ANDs them together and puts that value back on a stack. And that number that's going to go back on a stack is between 0 and 7. All right, so now we've defined it. Oops, I might have had too many cursor movements there. So we're going to try that again. There we go, took it that time. So now when we call the word rand color, we'll get a number between 0 and 7. So let's call this a few times and see what we get. There's a 4, there's a 1, there's a 4. Perfect, this is just what we need. Let's add this to our program. Okay, we're gonna go right here to our 0B ground, a line of code that we had from before, and we're gonna use the U key this time to enter text in under this line. So we're gonna put a space, and we'll say colon space rand color space 162 C at 7 and semicolon. And now we've added that line of code to our program. What's kind of interesting here is a little feature of the editor. You'll notice that the @ sign that we keyed in on a top part gets rendered as this kind of like sort of half horizontal line. There's 2 or 3 characters that the top part can't render for whatever reason. It's documented in the manual, so it's not like a bug or anything. But the @ sign that you see down there won't appear up there. So we're going to exit out of here. So now let's talk about color memory for a moment. The VIC-20 has a block of memory called color RAM, and it's located at memory address 37888. For those familiar with the VIC-20, color RAM and screen can be found in different memory locations depending on how much RAM you have in the VIC. But lucky for us, this version of Forth will put the screen always at location 4096, which we don't really care about for this program, but color RAM will always be at 37888 no matter how much memory is in the machine. Good, this makes programming graphics quite a bit easier for us. So we know that C at fetches a value from memory, but now we're going to be storing a value from memory. So the opposite of C fetch is C store. So let's put a value in the top left corner of the screen so we can change the color there. Clear the screen here, and we're just going to type a bunch of asterisks here. So we have something in the top left. We're going to press enter just to get the command interpreter ready for us to enter a command. So what we're going to do is we're going to put a 1 onto the stack, the memory address 37888, all right, and then we're going to use character store. When you see the exclamation point, think of the word store, and C means character, which means we're putting a byte. And what that word is going to do is going to pop the memory address off the stack, which is 37888. Then it's going to pop off the stack the value that we want to put there, which is 1, which is white. And we can tell here, if we do 37889, the next one, and we store it, it makes that one red. Cool. So we're going to make a constant for color memory. So let's also add this to our code real quick. So let's jump back into the editor. And let's go down to where our constants are, right here. And we're going to press U to put it underneath it. And we're going to put 37888 onto the stack. And we're going to call the constant word and call this constant color mem. All right, now we're getting somewhere. Okay, let's jump out of here. So what we want to do now is loop through the color memory for 11 characters. That's, of course, the number of letters in the phrase hello world. We want to generate a random number between 0 and 7, which we can now do with our random number routine that we wrote. And we want to store that number in each color memory address plus an index, so we can kind of give a different color to each character in a word. So how do we do that? Well, we need access to the index inside of our do loop. So if I was to define a word called D, which is going to be a do loop, it's going to go from 0 to 11, because remember when do runs, it pops the 0 and then pops 11, so it's 0 through 11. We have access now to a word inside this loop, which is the letter I, which is index. What that word does is it takes the current index and puts it on a stack so we can use it for things. For now, I'm going to use the word dot to pop it off the stack and display it so we can see it in action. And then we're going to put in a loop. And just remember, the words between do and loop are the words that are repeated 11 times. So now we've got this word defined, and if I run D, I'm going to see 0 through 10. Okay, so with this knowledge here, we're going to write the routine that does this. We're going to write it in the editor. So let's go down to this line here, rand color, and we're going to define our new word underneath it. So we're going to use a U, and we're going to define do colors. This is the word that's going to go through all of the letters in Hello World and assign a different color to it. So again, do is going to pop the 0, it's going to pop the 11, and it's going to do everything between here and the word loop 11 times. So the first thing we're going to do is call the word rand color that we defined. That's going to put a random color onto the stack. So let's pretend it puts a 7 onto the stack. Great. Now we're going to take the color mem constant and put that on top of it into the stack. Excellent. Now we're going to call I to put the iterator onto the stack. So that's going to be a 0. All right. Then we're going to use the plus operator. That's going to pop the 0 and color mem off the stack, add them together, and put that value back on the stack. Well, I is 0, so 3788 goes on a stack. So now our stack has the memory address at 3788 and the random color underneath it. Then we're going to call C store or character store, and that's going to pop the memory address off the stack. It's going to pop our random color, and it's going to push it into that memory address. Then we're going to call delay for our little short pause, and then that goes into a loop. Okay, let's pop out of here, and let's see if we can see this in action. So we're going to type in one load to run our program, and we're going to see hello world. And remember, we created those words, so do colors is still here, so I can type do colors, and we get some random colors. And every time I run this word, we will get different colors in there. Awesome. Now we're in home stretch. Let's finish this app up. So we're going to go into edit. Once again, I had that white background with a white cursor. So, okay, jump into the editor. We're going to add 2 lines of code right under here to do what we need to do. The first one is we're going to define a word go. That's going to do a loop 250 times and call our do colors word. All right, we're going to do another word under here where we're just going to call go. And that's our program. Let's give this a try. All right, let's give this a try. One load. And there we go. Feels like Christmas almost, doesn't it? All right, with the success of our cool hello world, let's save this up. So we're going to do a one write. Oops, let's try that again. Every so often it gets confused. And then we're going to go to our fake tape and we're going to record this. Fantastic. We're going to stop our tape. Then we're going to rewind it. So Forth is quite a portable language. The VIC-20 and the C64 actually do share a lot of similarities. So porting our code here to the Commodore 64 version of Forth should be pretty easy. So let's close this down and let's grab the 64 version of Forth and see how easy it is to bring this code over. So here we are in a Commodore 64 version of Forth by Tom Zimmer. So right away, all of a sudden it feels like we have so much space to work with. 40 columns never felt so big before after coming from a VIC-20. But the first thing we want to do is load our tape in. So I've got the fake tape in our fake tape cassette, and we're going to read it into the 64. And we're going to use the same commands. One, read. We're going to press play on our little fake tape here. Now what's interesting is the VIC-20 version would just load it. The 64 version blanks the screen while it loads from tape. And that pointer 4 here, it's going to say found program. There it is, it found it. And now it's going to load the rest of it. Excellent, we're all loaded. So we can type one list and we can see the program is here, and just like the VIC-20 version, there are 16 lines, except this time it's much easier to read because again, 40 columns never felt so so wide before on a screen. Now instead of just having 2 screens of code, the Commodore 64 version starts off with 16 screens of code, which feels absolutely mammoth compared to the VIC-20 version. Like I said before, the programs are very portable. So we're going to press one edit to bring up our editor. And the editor looks just like the VIC-20 version, again, just bigger. And the only thing we need to change is the memory address of color RAM. So we're going to press insert to go into insert mode. We're going to delete this. And on a Commodore 64, color RAM is at 55296. Press enter, and that's it. Everything else is exactly the same. So we're going to press run, stop, restore. And we're back at our prompt here. And again, just like the VIC-20 version, we can type 1 space load, press enter, and our program is going to run. And there it is, world's quickest port. So we're going to press run, stop, restore. Run, stop, restore doesn't restore the background color. Not a big deal. We'll just type in 6B brown to get our blue back. And there we are. So now that we have it loaded from tape, let's save it to disk. So in my fake disk drive is a blank disk. So the command we want to use is in parentheses, the word file, space, and we'll call it hello world. What this is going to do is it's going to create a new relative file, and it will store screen 1 of our source code into the file. You'll notice here that the drive light stays on. That's because the file stays open until we're done with it. So if we type in 1 space edit, we'll see that our page of code is here. And the way it works is if you want to save changes to disk and you've made some changes to the screens, you type in the word flush. It will then record any screens that have new data on it to the file. Now when we're done with our code, we type in fclose, which of course stands for file close. This will do the flush routine that we just typed above. In addition, close the file and release all of the pages of source from memory. And now that we're done with this, we can press run, stop, restore. The 64 version, aside from it having way more memory, they give you way more words to do neat stuff with. For example, there's a sprite editor built into it, and you can type in a sprite number and SPEdit, and you can create sprites with it, which is kind of neat. And then it'll build sprite data. There's a built-in assembler, and there's also sound routines to deal with a SID chip. And there's just a lot of neat stuff for writing games. There doesn't seem to be a way to take our program and save it or export it as a program that can be run without the cartridge. I know there are other versions of Forth that can do that. For example, White Lightning by Oasis Software lets you do that. And I know there's a version of Forth by Abacus, but I haven't played with that one yet, so I don't know if that has the capability. But these 2 versions of Forth, you have to have the cartridge to load and run the software. With that said, it's just an interesting language. It was really, really fun to play with. And I'm looking forward to exploring more languages on the Commodore VIC-20 and the Commodore 64. Once again, thank you for sitting through this video. I had tons of fun creating it, and I hope you enjoyed watching it. Take care.